Hello Honors Geometry students, welcome back. Today we're going to talk about the surface area and volume of a sphere. And this is going to fall under two different learning targets, 3C where we can compute, solve, and analyze the area of geometric shapes, and 3G I can compute, solve, and analyze volumes of geometric solids. Alright, so our technical definition of a sphere is a set of all points in space equidistant from a given point called its center. So when you think of a sphere, think of a ball. All right, when we think about the surface area of a sphere, that's the outside covering. So think about an orange peel. If you peel an orange, it's in the shape of a sphere, you lay it flat, that would be like your surface area. And to find the surface area of a sphere, you're going to take 4 pi r squared, where r is the radius of the sphere. Okay, so in example 1, the diameter of a ping pong ball is 44 millimeters. We want to find the surface area. So remember, diameter is all the way across, so that's 40 millimeters. Our radius would be half of that, or 20. So if our radius is 20 millimeters, and our surface area formula is 4 pi r squared, we can think of 4 pi times 20 squared. Now keep in mind that you can do this as an exact answer or as an approximate. If I want to do this as an exact, I'm going to take 4 times 20 squared to get 1600, and it would be 1600 pi, and I'll be dealing with square millimeters because I'm dealing with the surface area. So even though it's around a three-dimensional shape, it's in the shape of a sphere. When I lay it flat, that's what I'm talking about in terms of area. But if I want an approximate decimal answer, I would take 1600 times pi, and in my calculator, I get approximately 5,026.5 square millimeters as my surface area. All right, cruising along, volume of a sphere. Think about how much air it takes to fill up a basketball. So how much volume, how much stuff is fitting inside of that sphere? The volume of a sphere formula is 4/3 pi r cubed, where a radius is r. So on your calculator, if you want to type in 4/3, you might deal with 4 divided by 3. On your calculator, there's also a pi key, which we've been dealing with a lot. And if I want r to the power of 3, let's say my radius is 5, on your calculator, you might have a little caret key that looks like this, or you might have the y to the x key, or in the Graph and Calc app, let's pull that up, 5 to the power of, see that key over here on the right hand side, 5 to the power of 3. So that's how we can take care of that. All right, so if we want to take a look at example number 2, if I want to find the exact volume of a sphere that has a diameter of 11 feet, my diameter is 11, so my radius is going to be 11 divided by 2. Personally, I'm going to keep my radius in terms of a fraction because I want to find an exact volume. So that means I don't want gross decimals along the way. So my volume is 4/3 pi r cubed, so pi times 11 squared cubed. When I cube a fraction, that's like cubing the top and cubing the bottom. So 4/3 pi, 11 cubed is 1,331, and 2 cubed is 8. I know that 4 divided by 8, I can think of that as 1/2. 1331 is not divisible by 3. I get some sort of gross decimal. So if I want to multiply my tops, I have 1 times pi times 1331, which I'll write as 1331 pi, over 3 times 2, or 6. And I'm dealing with cubic feet for my volume. All right, cruising along. Example 3, and I believe this is a true story, I think it's in our textbook somewhere. On July 16th, 1882, a massive thunderstorm over Dubuque, Iowa produced huge hailstones. The diameter of some of those hailstones was 17 inches. So just take a moment, visualize a hailstone that is 17 inches wide. That's ginormous. I would not want to be hit in the head by that hailstone. We are told that ice weighs approximately 0.033 pounds per cubic inch. What's the approximate weight of these hailstones to the nearest pound? All right, so in order to figure out how heavy this is, notice there's a clue here. We're given per cubic inch. What's in terms of cubic inches? Cubic units, we're thinking volume. So we want to figure out how much volume is hanging out inside this giant ice chunk. So we're thinking volume equals 4/3 pi r cubed. It doesn't say anything about exact. In fact, we are rounding to the nearest pound, so I'm going to keep things in terms of a decimal. That's just fine. So my radius is 17 halves, or 8.5. So if I plug in my calculator, I'm going to hit up 4/3 times pi times 8.5 to the power of 3. And I get 2,572.44, and I'm dealing with cubic inches. All right, so I know how big it is, how much volume's in there. Now I want to figure out the weight. If I have 2,572.44 cubic inches, and I know that 1 cubic inch is 0.033 pounds. Notice how I'm doing this formula. This is something that you might hit up in chemistry class later on about how to deal with units. I know I want to get rid of inches cubed, so when I'm looking at my fraction, I want inches cubed hanging out on the bottom. So I'm left with my the unit I'm looking for. I want to know the weight in pounds. So that's how you can decide if you're going to multiply by 0.033 or divide by 0.033. All right, so then we'll go back to our calculator, times 0.033, and I get to the nearest pound about 85 pounds. Watch out, you do not want that hail to hit you, because that's the size of a small human. All right, cruising along then. Example 4, and then I have a bonus example in here because I came up with one more type of question that you may want to deal with. All right, example 4, we're dealing with the circumference of a sphere. If I want to draw a sphere 3D style, I start with a circle, and then I draw this outward curve, and then I can show the back part of it with a dotted line. And we know the circumference, so all the way around the edge of that sphere, so think like equator. The circumference of that sphere is 10 inches. It's our job to find the volume. Well, volume, the one thing that we need to know in order to find volume is radius. Think back to circumference in our last unit. Remember, circumference is 2 pi r. So, if 10 is equal to 2 pi r, I can divide both sides of my equation by 2 pi to get r by itself. All right, make sure that if you're going to hit up your calculator, you want to put that 2 pi in parentheses. Otherwise, your calculator is following the order of operations, meaning that it's going to divide 10 by 2 to get 5 and then multiply that answer by pi. We don't want that. We want to divide by the product of 2 pi. When we do that, we have that our radius is approximately 1.59. Okay, and we're dealing with inches. Okay, so now that we have our radius, we can plug into our volume formula. So I will type into my calculator 4 divided by 3 times pi times 1.59 to the power of 3. And I went to the nearest tenth, so that's going to be 16.8, and I'm dealing with cubic inches. Okay, one more type of problem to deal with. So my bonus example number 5 says the volume of a sphere is 300 cubic inches. We want to find the radius. So volume equals 4/3 pi r cubed. So we're going to plug in 300 for V. So 300 equals 4/3 pi r cubed. All right, so first thing that I'm going to do is I'm going to multiply both sides by 3/4. Multiply both sides by the reciprocal. And I end up with 225 equals pi r cubed. Next thing I'm going to do, I'm going to divide by pi. And that's getting me to 71.6 equals r cubed. Now this is something that you might not have dealt with, at least in a long time, the concept of getting rid of cubed. So remember, if this was 71.6 equals r squared, we would take the square root. But to get rid of the cubed, we're going to take the cubed root. So hanging out on our calculator, we have a couple of different ways to deal with, depending on what calculator you're using. Well, regardless, we're going to take the cube root. Okay, so divide it into 3 equal pieces. So something times itself equals 71.6. So you have some different options for how this button might appear on your calculator. You might have a button that looks like this. Actually, probably no X in there. Or you might have a button that looks like this. All right, let's see what we actually have. So if I hit up math, here's my two different options. They're hanging out at number 4 and number 5. So I can take the cube root of 71.6, and I have 4.15 as my radius. The other option, if you have a different button on your calculator, is step number 5, where it has that X for the root. If you want to use that, you have to first define what that root is. We want to take the cube root, so we're going to type in 3. Go back to that math mode, hit option 5, and get 71.6. We still get 4.15, and we're dealing with inches for our radius. Okay, so our cubed root. All right, so your homework to try to take a look at this, we're in section 6.6 in our textbook, page 340, 2 to 12 even, 13, 15, there's something funky with my copy, you can't see 16, so you can skip that one, 17, 19, 23, 25, and 26. All right, please let me know if you have any questions, and I will see you online. Bye.